Good evening. I forgot to record any of the classroom notes during the day, so I am putting this together tonight for those of you who were gone and those of you who wanted to revisit the ideas that we learned in class today. So the name of our lesson is Graphing More Complicated Rational Functions. And as I explained in class today, you will not be responsible for choosing a graph or creating a graph for our assessments. The only thing you need to understand is the characteristics of the graph, and then we'll use Desmos to see the actual graphs. So these beginning notes, before we get into the homework notes, helps you identify these certain characteristics of rational functions, and each one of them have a purpose. So the first one I want to talk about is the wholes. If I can get that highlighted, there we go. The wholes of a complicated rational function appear when, after you write the function in factored form, as it says on the worksheet here, you notice there are two of the binomials, one in the numerator, one in the denominator, that are, see if I can get this to still highlight, there we go. Nope, it took away. Okay, that look alike. Okay, there we go. I guess that's what I have to do. And they're both x minus 3. So the whole for this example is when the factor set equal to 0 is the same at the top and the bottom, numerator, denominator, and the value of your whole is a number. Because the x value, when it makes the numerator and the denominator 0, doesn't have a y. So the whole is a position on the graph where the y is undefined. That's different than an asymptote, that's a line, that's where no points exist on the graph, the graph won't cross that boundary where x is a -2. So that's a unique thing for a more complicated rational function. And notice the first thing you have to do is factor. Okay, the first thing you have to do is factor. So they're not going to let you forget that's important to know how to do. So they have the original function, x squared plus 2x minus 15 over x squared minus x minus 6, and then you put it in the factored form. So they factored x squared plus 2x minus 15 into x plus 5 and x minus 3. They factored x squared minus x minus 6 into x minus 3 times x plus 2. I'm just going to move that up just a little. There we go. So that's your first characteristic. The next one they want us to take a look at is the x-intercepts. And I think on the homework I had it in a different color, but I'll pick green since that's all I have to choose from for this video. The x-intercepts, they appear when you look at the numerator and there's a factor that's not a whole, because wholes are wholes. That's all it can be. If it's a whole, it's nothing else. So you get your x-intercepts from the numerator, okay? And then you set that binomial equal to 0, solve it for x. You write it as an ordered pair, and you've got yourself the x-intercept. The reason that is because the y is 0. So if I put a 0 here in this function in place of the f of x, and I go to solve for x, I'll multiply both sides by this denominator, and it disappears. So all you have left then is the numerator, and so that might help you remember where to find the x-intercepts from the factors of the numerator that are not wholes, but you can use this information, you know, if you take notes on it, use this information, and then you'll be able to study it, understand it, and apply it. Okay, the y-intercept then, I'm going to give it the pink color, and it shows up when we put 0 in for x. So if 0's in for x, all that's left from the two polynomials are the constants here. Let's see if I can get that. There we go. And the negative 15 over the negative 6 reduces to 5/3. Therefore, the y-intercept is when x is 0, your where it crosses the y-axis is that relationship between the constant terms of the polynomial. So now we'll look at, just one more characteristic that we learned in 8.1. So they didn't have it listed in this list. They just have the word vertical asymptotes because that's what we learned last time. The vertical asymptotes come from the zeros of the denominator. So we look in the denominator. Let me see. I think I can't remember what color I made that guy. Blue. There we go. So the vertical asymptote, you look at the denominator and it's which of these factors are not from a whole. You set it equal to 0. And then you've got yourself the line. Remember, an asymptote is a line where the graph doesn't exist because it made the denominator 0. So there's your map. That's where you find everything. You find your vertical asymptote from the factor of the denominator. You find your wholes if there are factors in common to numerator and denominator. Now, they're not always a whole, so you don't have to worry about that. And then you find your x-intercept from the factors in the numerator that are not wholes. And then you find your y-intercept by, let's see if I can make this pink, by changing the constant terms of your polynomial into a ratio and reduce it. So remember, x-intercept's definition is that's when y is 0. Y-intercept's definition, that's when x is 0. That's the point on the graph where it crosses the x-axis and where it crosses the y-axis. So if we look at these examples, I don't know how good my writing is going to be here. Let's see. We're looking for a vertical asymptote. Okay, first things first. We need to, here we go. We need to factor. Maybe I can use my typing. That might work better. Okay, that's not going to work. I got it messed up here. Delete, delete, delete. Okay, so I'm going to go make a text, put it on this line over here. There we go. Actually, I want to create a fraction. It is x plus 6 because you cannot factor that anymore. And then our denominator, and that's really small. See if I can make my text larger. That's a mess. Okay, let's see where I can make my text larger. Text selection. Okay. Oh, here it is, up here. Okay, I want my text bigger. That's about right. Okay. Okay, I'm going to go ahead and put the denominator, and then I'll underline that numerator. I'll underline that guy right here. Underline. There we go. And then below that, okay, I don't want it underlined. I'm just, oh, it disappeared. Okay, I guess I can't do it. Okay, and so x squared minus 4x minus 12 factors into x minus 6 and x plus 2. There's my two factors in the denominator. If I can get this, maybe I can just use this pen and draw a I can draw it over that or not. There we go, a fraction. Oh, not bad. So we look and code our vertical asymptotes. That's a blue color. Vertical asymptotes, we find what makes the denominator 0. Since there are no holes, we'll type that there. There are no holes because there were no look-alike factors. There was a matching factor in the numerator that looked like a factor in the denominator. These two are close, but they are not alike. So then I can go back to my vertical asymptote. Okay. I get it from these two, those two down there. I don't know if I'll be able to highlight it or not. What makes x minus, it doesn't look like I'm going to be able to highlight it. So I'm going to look in the denominator. Oops, I got all sorts crazy. There we go. That'll be for the vertical asymptote. I can put that down for the x-intercept. Okay, vertical asymptote. Well, if I can make that pen color a different color or not. No, it doesn't say. Okay, so I'll just type in their vertical asymptotes, their lines. So it's x equals 6, because that's what makes x minus 6 0, and x equals a negative 2. And that's what makes x plus 2 0. Okay, the x-intercepts then, they come from the green. That is the numerator. What makes that 0? And it's a negative 6, but I have to write it as an ordered pair. For the x-intercept, the negative 6 is the x value, and 0 is the y value. Definition of a x-intercept. Then a y-intercept is, go back to these two. If I can draw this. I look at these two and reduce. So my y-intercept comes from, if I take 6 over a negative 12 and reduce it, it's 1 over a negative 2. So the ordered pair is 0, negative 1/2. Okay, that is your y-intercept. So this color coding will really help you I spy with your educated eye the values of what they're asking for. So I don't know if it's going to let me highlight over my text or not. So vertical asymptotes came from the denominators here, that one. And I don't know if I can, it won't let me highlight that. Okay. I factored the denominator and got those values. Holes, there weren't any. X-intercepts come from the numerator. What makes the numerator? Doesn't look like it's going to let me highlight. What makes the numerator 0? And you have to write it as an ordered pair. And then the y-intercept is that interesting relationship. That's when the x's are 0. So here's the algebraic in the story. You put x's in for 0 in step 3, but it ends up you just take those two values, the 6 and the negative 12, and reduce. So that is a y-intercept. Oops, that's crazy. That came, and I can't highlight on that. Came from there, there's the pink over the green, and from there, there's the pink over the negative 12.